At this time, I'd like to reintroduce Dr. Zhang. As I mentioned this morning, Dr. Zhang is a professor with the Department of Civil and Environmental Engineering at the University of South Florida. Dr. Zhang leads the Smart Urban Mobility Laboratory at USF and serves as the director for NICER, the National Institute for Congestion Reduction, which is a US DOT National University Transportation Center. In addition to some of the information that I presented before lunch, Dr. Zhang is actively involved in professional organizations. She served as the chair for Transportation Research Board, TRB, Airfield and Airspace Performance, AV060 Committee, and the president for Chinese Overseas Transportation Association, or COTA. Dr. Zhang also serves as the president of Women in Transportation Seminar Tampa Bay chapter. Please welcome Dr. Zhang once again to the stage.
Thank you very much for the introduction again. First of all, I'm really glad to have this opportunity to be here and share our research at USF regarding advanced air mobility with all of you. And I thank Tampa Bay Smart Cities Alliance for organizing this conference. And I think it's a very timely movement for our Tampa Bay region to get people more involved into these emerging transition modes. And I thank those who visited our posters and give comments to our students. So our speakers in the morning have given very, very detailed information about what advanced air mobility / urban air mobility is. So I will not repeat those. And I think the takeaway point is that it's a new transition mode that taking advantage of the distributed propulsion system and also the advancement in the information technology as well as in the satellite-based navigation service system and also the connectivities, etc., to enable this new transition mode that can be used to transport the passengers and cargoes by using the low-altitude airspace, and it can serve the rural area, to serve the underserved communities, and provide better access and alternatives to the potential users. So our speakers in the morning also mentioned about the certification of the new aircraft. So far, I think 2 companies in the US have submitted the requests for the certification from FAA. So our FAA representative has given more information on that. I also want to share with you there's some agreement between countries, letter agreement, for example, between European Union and the US. So US, following the process, is setting up the certification standards dependent on the design of the vehicle. And the EU, they want to follow a more consistent process to certify those vehicles. However, they agreed, there should be harmonization and transferability between the different countries. So in the morning, there's a very comprehensive list about the OEMs who submit the certification requests to the different aerial navigation service providers in their own countries. So the optimistic prediction is that probably in late 2024 or early 2025, we will see some of the vehicles being certified by the ANPS, and then it's possibly get into the market very quickly. So FAA actually published the COP for the UAM several years ago. And if we look at the different stages, they actually envision 3 evolutionary stages for the UAM operations, talking about initially just taking those as a general aviation and providing the air traffic control services if the vehicles go into the controlled airspace. And in the midterm, FAA liked the idea about having a corridor to be used by the UAM aircraft. And talking about, the autonomous technologies, maybe with a remote pilot instead of the single pilot in the cockpit. And then later, of course, match the mature stages that are defined by NASA as well, is that in the future, we will see higher density, we will see more flexible usage of the airspace, as well as the fully autonomous of the vehicle. And NASA actually put lots of effort besides the UTM, the U.S. traffic management systems that they have been developing and testing with the help of different U.S. test beds across the country. And one initiative is focused on the safety. So NASA's mission is to ensure the vehicles used by AAM could operate safely in the integrated airspace. They launched the system-wide safety project, which is called IASMS. And there are several focused areas, including data, resilience analysis, strategic conflict management, tactical conflict management, et cetera, et cetera. And at USF, also for the academic research community, we try to target on those challenging problems and also sometimes look a little bit ahead of the future and to see what kind of situation that we will encounter while embracing this new mode. So I will give a couple of sample projects that we have been worked at USF, and actually we also have the posters there if you want to see a little bit more details. Now, as Alice introduced, I'm leading the Smart Urban Mobility Laboratory. And about 6-7 years ago, besides other research, we started doing research in the AM/UAM area. And following that effort, we actually launched a new research program at Qatar. Qatar is Center for Urban Transition Research. It's pretty well known in Florida and beyond for their research in public transit, in the emerging areas. So we actually consolidate expertise from civil and environmental engineering department, as well as computer science, industry and management systems engineering, electrical engineering, and also mechanical engineering. At USF, our mechanical engineering will soon become mechanical and aerospace engineering. So we consolidate the expertise of different faculty members and researchers from all these departments and establish this research program at Qatar. And we are conducting research on passenger AAM, cargo AAM, and also UAS applications in transition field. So the first project is we look into the network design including the locations where to put the vertiports, what are the optimal locations, and also considering the interactions between the location and the potential user's mode of choice. We did this integrated modeling and solve the problem and give us some ideas about, for example, in Tampa Bay area, where those vertiports could be, and also how many ground trips actually will divert to the multimodal AAM if the AAM became available in Tampa Bay region. And also in the morning, the speakers mentioned about the multimodal. And we, especially for the urban air mobility, we want to put that into the multimodal perspective and considering the connections between the potential AAM and the existing transition modes that were already available or can be expanded to fulfill the needs of the future AAM. So our study look into this and give a good sense about, okay, in the future, if we want to put 10 vertiports, 20 vertiports, 30 vertiports in our Tampa Bay region, where they could be and should be and best to be. And then how much traffic it will attract and what would be the system level benefits that we can gain in terms of save the travel time and reduce generalized travel cost. The next sample project is we look into how we can help the future service providers to support the AAM, which is called a PSU. So In the FAA's vision, in the future, given the higher density of the AM, the air traffic information and also monitoring and management were not done by the current human-based air traffic control system. Instead, the third party will provide this automated AM traffic management system and serve the service providers. So one challenge that we looked into is a strategic conflict management, and then the outcomes actually could be used for the planning purposes and used by the private stakeholders if they are considering of launching that kind of service. So for this, we first look into the airspace management, and our idea is to take advantages of both the structured system as well as a free flight network. So our idea is to propose a leveled airspace, and at each level we would allow the vehicles to fly directly as much as they could by avoiding the discouraged airspace. Those discouraged airspace could be where high density of the commercial flights are actually going through, or some restricted airspace. And I will not go into the detail, but the idea is that for hundreds of simultaneous operations in Tampa Bay region, we actually could run the model and come up with 4D conflict-free trajectories by assigning those vehicles on different flight level, by displacing their departures slightly. And we can achieve that and provide the pre-departure planning for the service providers. So what is ongoing efforts at USF? Currently, we're working together with FDOT on one of the projects. Is we try to evaluate the impacts of emerging advanced air mobility on the transportation systems in our region. And how we do that is we incorporate this new mode into our statewide model and focus on our study area, which is Tampa Bay Region Plus. So besides the 5 counties in District 7, we also include the Sarasota and the Manatee into the map. So we have finished enhancing the statewide demand modeling. I will show later is that we enhanced the script so we can add the vertical locations, we can add the potential air routes, and then let it become a new mode and running the statewide demand modeling. And another thing is we generate a route network for the planning purposes, which I will also elaborate a little bit later. So this is the part of enhanced script in the statewide model. So in the future, if we know the locations of the vertiports, then we can import all of them into the statewide model. And then based on the next study I'm going to mention, we could create those air route network that will give us the estimated travel time, travel distance, and maybe other variables that we need in the disutility function while we do the demand modeling. So for generating the air route network for planning purposes, we actually collected the trajectory data. There are different ways of doing that. One is we could use OpenSky resource for collecting the trajectory. Another one, of course, we can obtain that from FAA. So we actually have both. We have finished doing the trajectory from OpenSky, but now recently we got historical trajectories from FAA as well, and we're going to do that parallel with this OpenSky trajectory analysis. So here just to show a couple of days in Tampa Bay region and what the trajectories of the flights look like. And from there, we want to identify what we call the discouraged airspace. So the discouraged airspace is considering densities of the commercial flight trajectory. The dots there, the size of the bubble there actually indicates the frequency of the flights going through those cells in the airspace. And from there, we can do clustering and obtain those colored cells. So those colored cells are the cells with a high frequency of the commercial flights going through, and was were identified as a discouraged airspace when we do the air route design for the AM. So then we can apply, visibility graph or some other methods and determine the air route from one vertiport to the other. So here is just a kind of, for demonstration purposes, we assume there are those other locations, the dots are the locations of the potential vertiports, and also at a different level, airspace level, there are discouraged airspace. Then go from any vertiport pairs, what the air route should look like. And another thing is, this morning, actually, Brett mentioned their efforts of identify the best locations for putting the vertiports at Tampa International Airport. And several years before that, we also looked into Tampa International Airport and tried to explore if there are vertiports on the airport or near the airport. Then, given the existing commercial flight operations, can we find the in and out procedures for the VTOL operations? So we looked into 3 candidate locations. Actually, those are not suggested by TPA later. One is on the rooftop of economy parking. Another one is on the rooftop of the main terminal. And the off airport is the helipads that is currently used at Raymond Stadium. And then we obtained the trajectory and using the PDAS to replay that. And then we used the machine learning search method to design the procedures for the VTOLs in and out. So that actually touched on the airspace integration that Brett mentioned. So we will be more than happy to duplicate this research given the suggested locations from the Tampa International Airport for the vertiports on TPA. And we also obtained some funding from FAA, try to understand, from the, if at the early stage, the AM is considered as general aviation, and if there's a vertiport on the airport, then from air traffic controllers' perspective, how that would affect their workload, and how much operations they are possibly accommodated dependent on the different runway configurations that they're using and the different weather conditions. So we're going to collaborate with Tampa International Airport and look into that. So we're going to recruit some air traffic controllers to obtain their perceptions and comments and suggestions. So we have more study, and given limited time, I cannot share all of them with you, but you're more than welcome to visit our website, which is listed here, and my email address. So if you have any follow-up questions, if you want to know more information, if you want us to present during your meetings, please let us know. We will be more than happy to do that. Thank you very much.
Okay, don't go anywhere. Any questions for Dr. Zhang?
Great presentation. I was curious if you're using Unreal Engine or Unity gaming engine technology for some of your data visualization, and also if you've heard of Cesium and their integration with Google Maps to be able to do the full volumetric and type of digital twin for what you showed today.
The answer is no. So currently when we do that, we use more of the GIS tools to visualize the trajectories. And we also could use some software actually developed by companies with the sponsorship of FAA to do that. I didn't mention we also developed a simulation tool, and that simulation actually we used the analogic by combining the GIS map and also the functions in the analogic to show how the future AM could operate. And then from there, we can identify the bottleneck. Honestly speaking, when I look into the system, it has lots of similarities with the existing station-based shared mobility. So we call it shared and potentially on-demand advanced air mobility. And we use those tools, to simulate the operations. So, but thank you. I would love to look into that to see if we can use those tools as well. Thank you.
Hello. So with the integrated network design and demand modeling, did that take into account the I know that there was the time savings and looking at the papers. There's some looking at energy or carbon and those types of things, output. Was there a look at the cost and acceptance of the cost difference to see how that demand would be handled, as well as and this might be too into the details, but these are the details I'm worried about, from a policy, or even if it is allowed in those areas that you looked at. Like, is it in the middle of a residential neighborhood, or is it more of a commercial area, those types of things?
Yeah, good question. I didn't give enough details when I was presenting. So first, for that study, we identify potential candidates. When we do the candidates, we look into land use, try to put them more in the commercial space, not residential areas. And we look also at if there's enough space. Doesn't matter if it's rooftop or open space. So we use some GIS tools to help us to identify those candidates. And then from there, we actually used some disaggregate demand from the activity-based model in Tampa Bay, and then consider the available ground transportation for access and egress to and from the vertiports. So we also calculate the travel time and the travel cost, considering from the true origin to the true destination, and then compare the travel cost and the travel time of the multimodal AM versus existing ground transportation. So yes, the potential passengers will make decisions by taking these two into account. And of course, from the demand modeling perspective, there are other factors that we could consider, like a comfort or safety, et cetera, et cetera. Yes, so we have more details in the paper, and I can give you more details if you like. Yeah, thank you.
Dr. Zhang, thank you very, very much. Let's hear it for Dr. Zhang.
Thank you very much.